So in this triangle here, I want to know DC, right? I want to know how big X is. Again, that's not in a right triangle. So what I want to do is locate a couple of right triangles that I could then find sides of and kind of piece together here. The nice thing is, really with the stuff that we're going to stick to, there's going to be two right triangles. One will be very, very obvious. One will be a little less obvious. So I have those two right triangles right there. Just highlighted, one in green, one in blue. And what I'm going to do is I'm going to find AD. I'm going to find AD. And I'm going to find AC. And then what I'm going to do to find X is I'm going to subtract AC minus AD. Okay, so this is what I want to do. That's my plan right there. So now I got to take those two right triangles and see what I can do. I can do SOHCAHTOA very rarely, but in this case right here, I'm actually going to do Pythagorean theorem. Now look at just the green triangle. I have the hypotenuse of the green triangle right there. All right, and I want to know this right here. I'm going to call this little side, call it A. So now what I'm going to do is I'm going to do the Pythagorean theorem. So A squared plus B squared equals C squared. The 14 is the C, so 14 squared. And then I called that A, so I'm going to go A squared plus 10 squared. And then I'm going to solve that side right there will give me the side AD that I'm looking for. So I'm going to get A squared plus 100 equals 196 minus 100. And I'll get A squared equals 96. Take the square root. And I get 9.797. So A equals 9.797. And that is side AD. So I took that side, taken care of. Now I'm doing the same thing with the blue triangle. I gotta be a little careful here because it's hard. 14 has nothing to do with the blue triangle. The X actually has nothing to do with the blue triangle. But in this triangle, I have the hypotenuse right there. And then I'm going to call this side B for the blue triangle because I want to know A all the way over to C. I'm going to do Pythagorean theorem again because there's no angle to talk about. So I'll do A squared plus B squared equals C squared, which will give me 10 squared plus B squared equals 16 squared, which is 100 plus B squared equals 256. I'm going to subtract 100. So I'll get B squared equals 156. I'll take the square root of that. And I get 12.489. So B is 12.489. And that is AC. So my plan was to take AC minus AD. And again, why am I doing that? Because if I know this whole distance from here to here, which is AC, and then I know this distance right here, which is AD, and I subtract it, it will leave me with this thing right here, which is what I want when I subtract those two numbers. So I'm going to subtract these two right here in my calculator. So I'm going to grab that one, and I'm going to subtract that one. And I get 2.692. So when I subtract them, I get 2.692, blah, blah, blah. It says nearest tenth, so I'm going to round that 6 using the 9, and I'm going to get 2.7.